Hi, and welcome to topic number 26. This topic is called students T distribution. So this is another type of distribution. All right. Oh, sorry about that. Students T distribution. Let me type this. So the students T distribution is used. Okay, this is what we're going to end up using. Is going to be used to calculate the margin of error for a population mean when the population standard deviation is unknown. So that's what topic 27 is going to be about. Okay, where we're going to population standard deviation is unknown. So when we do not know the population standard deviation, okay, we cannot use the critical value of Z anymore. So we can actually end up using this thing called the student's T distribution. All right, student's T distribution, the reason why we call it is because William Gassett, okay, is the one that published this student's T distribution regarding the, back in 1908. His publication, you know, he's the one actually credited to publish the student T distribution. So he actually did that while he was working at Guinness Brewery in Dublin, Ireland. Okay, so when he was actually coming, publish this, he was taking samples of those barley, and it wasn't a lot of sample. The sample size was very, very small. So eventually, that leads to this thing called the student's T distribution. The word student is the reason why there's a word student is because William Cassett uses pseudonym, okay, when he made that publication. All right, so let's take a look at a few facts about student's T distribution. It's also bell curve shape, center about 0. It only has one parameter. It's called degree of freedom. Okay, the only parameter of the student T distribution is degree of freedom. Degree of freedom is always a sample size -1. Why is that the case? We don't know. Nobody ever knows why it's always n-1. It's just for some reason, when you take a sample -1 for the degree of freedom, your answer tend to be a little bit more accurate. All right. Student T distribution has infinite many distribution curves. This thing can be infinite number of curves. Okay, lots and lots and lots and lots of same curve. However, though, it become approximately normal when the degrees of freedom increases. Okay, as a sample size increase or degree of freedom increases, then it become approximately normal. All right, in general, the value of T such that an area of alpha is to the right of T. So this symbol, I know it's kind of hard to read, is actually T sub alpha. Okay. So normally, we talk about the value of T sub alpha. Alpha is referring to the area to the right, okay, of that T value. All right. So some calculator can do the T can find the T value just like finding the Z. Some some calculator cannot. So I'm going to show you how to find T value from the table. Okay. So consider the value of T such that 0.025 of area under the curve is to the right of T. So 0.025. So let's say the T I'm looking for is right here. The area to the right, this bit of area is only 0.025. Assume degree of freedom is 13. All right, so let's look up table, okay? So I created this T value table. I only can fit so much sample, fit so much of the table in here. So this thing actually go all the way to about like 50, then jump to 50, 60, 70, 80, 90, 100, so on and so forth. So the one that we commonly use is not that big. So if you look on the top horizontally, the top side says area in one tail and area in two tail. The first column is referring to the degree of freedom. So everything in the middle are the T value. So we're looking at area to the right, 0.025. So that's area in one tail. Go down to degree of freedom is 13. So that will be 2.160. So the T value is 2.160. Okay. Let's try another one. Consider the value of T such that the area to the left of negative T plus the area to the right of T is equal to 0.2. So right here, you got two T value, right? Center at 0. So the T value on the left is negative, T value on the right is positive. So the area to the left, this red mark here, left and the right is 0.2. So this is area of two tails. All right, degree of freedom is 23. So let's look up on the table. Area of two tail is 0.2, right? Right here, area in two tails. Degree of freedom is 23. So let's go down to 23. So that will be 1.319. 0.2, area of two tails, degree of freedom 23. All right, so the one on the right is 1.3. Oh Lord. What did I say? 319, yeah, 1.319. So that means the one on the left is negative 1.319. So I got two T values. A negative 1.319 and a positive. All right, consider the value of T such that the area under the curve between these two is equal to 0.95. So all this is 0.95. Okay, the table only displays the area of the tails, right? So if the area in the middle is 0.95, so then the area of two tails must equal to 1 minus 0.95, which will give me 0.05. All right, degree of freedom is 8. So let's see what the two T value is, okay? All right, 0.05. 0.05 is area of two tails. Okay, area, so degree of freedom is 8, so that'll be 2.306. So the one on the left is negative 2.306. There you go. Those are my T values. So again, we will be using that table for the next topic, okay? How we actually estimate the population mean with population standard deviation is unknown. All right, so please use a table to find those T values. All right, so thank you for watching.